All right, number 7, this is a graphing one. This is probably the one that there was the most struggle on, so let's make sure we do this one thoroughly. So first things first, for number 7, you want to list the transformations in order. So once again, this is pretty much like the questions we just did. What's the first transformation you see?
Vertical stretch by 2.
Vertical stretch by 2. The 2 on the outside tells you it's a vertical, and then since it's greater than 1, it's going to be a stretch. So vertical stretch by 2. Okay, what is the next transformation you see?
Right 3.
To the right 3 because of the minus 3 on the inside of the parentheses. That's right. The last one would be down 2 because the minus 2 on the outside of the parentheses at the very end. Okay? So now for this, we're going to use the table. All right? So remember, we always use the same 5 basic starting points. What are those 5 points? And what are the y values for those points? That's right. These are the basic 5 starting points always. And then you're going to change the values in the table based on each transformation. Okay, so you got to go in order. The first transformation is a vertical stretch by 2. What would that do to my values in the table?
The y values will go up.
The y values, and how do you know it's the y values?
Because the vertical is up and down, so that means the y is up and down.
That's right. Vertical is up and down, which means it's a y. X is left and right, right, which is horizontal. So it's a vertical stretch by 2. So what would I do to all my y values if I'm stretching them by 2?
Multiply by 2.
Multiply them all by 2. So what would my new y values be after I apply the vertical stretch by 2?
8, 2, 0, 2, 8.
That's right. So far that's where we're at. We took care of the first transformation. The next transformation is to the right 3. What would happen to the values in my table if I'm moving to the right 3? So think about moving to the right. Is that adding on the number line? It's adding. Right on the graph would just be adding 3. But what are we adding 3 to? The x's or the y's? It's the x's. Remember, right and left is horizontal movement, right? That's your x values. So to all the x values, we're going to go to the right 3. So that's just adding 3 to everything. Plus 3, plus 3, plus 3, plus 3, plus 3. So what are my new x values then? If I add 3 to all the x values. Bless you. 1,
1, 2,
2. What's 0 plus 3?
3,
3. What's 1 plus 3?
4,
And what's 2 plus 3?
6,
2 plus 3.
5.
5. Okay, so these are my values so far now. I've taken care of the going to the right 3. My last transformation is going down 2. So what would that do to my table values?
Subtract 2.
Subtract 2 from x or y?
1.
Y. Remember, y would be vertical, which is up and down, right? So anything that has to do with up or down, you change the y values. So down 2, so I just subtract 2 from all my y values. And so what are my final y values? 6, because we got 8 minus 2, and then 0,
2,
negative 2, 0, and 6. Okay, so then those outermost values, those tell me the coordinates for each point. So one of my points is 1, 6. That's right, I think here. Then we have 2, 0. So right here. Then we have 3, negative 2. We have 4, 0. And we have 5, 6. Like this. And just connect the graph. Make sure it looks kind of curved. It's supposed to be a parabola. Some people are still, drawing absolute values. All right, so there it is. And now let's find all the attributes that it asks for. So first it says opens up or down. You can just look at the picture. Does it open up or does it open down? Up. Is the vertex a maximum or a minimum? A minimum. The vertex is right here. Okay? And what is the domain? This is always the same for any quadratic. All real numbers, or you can write negative infinity to positive infinity. What is the range then? Negative 2 to infinity, right. It's the lowest y value, which is right here, at negative 2. And it never stops going up.
Negative 2 has a bracket.
Negative 2 is a bracket, right, because we're actually touching the point negative 2. And then around the parentheses, that was a spoiler. Around the infinity sign, it would be a parentheses, because that's something you can never reach. All right, where is the vertex? 3, negative 2, right. There's the vertex right there. So the axis of symmetry always goes through the vertex, so what is the axis of symmetry? X equals 3, very good. And notice the axis of symmetry is always x equals the same x as your vertex. All right. So, okay, the y-intercept is like off the page. But how can you find the y-intercept though? Plug in 0 for x, right. So when you have vertex form, this is vertex form, right? To find the y-intercept, just plug in 0 for x and then solve the equation. So watch like this. It's going to be 2 times 0 minus 3 squared minus 2. And when I solve this, that will give me the y-coordinate for my y-intercept. So what's the first thing I should do here? The what?
The square.
But we can't square yet because I don't even know what's inside the parentheses yet. Right, first fix what's inside the parentheses. So it's going to be 2 times 0 minus 3 is negative 3 squared minus 2. The next step now is to do what? To square that negative 3. But what is negative 3 squared?
9.
That's positive 9. Because negative 3 times negative 3 is positive 9. So now I'm at 2 times 9 minus 2. What is 2 times 9? 18 minus 2, which is 16. So doing this, plugging in that 0 for x, that gives me my y-intercept, which is going to be at 0, comma, what was the number we just found? 16. Microsoft Word's pretty glitchy. Wait, where's my other stuff? Okay, well. 0, comma, 16. Okay, the x-intercepts are exact. You can see where they are. What are the x-intercepts here?
2, 0.
Right, you see right here, that's 2, 0, and then what was the other one? 4, 0. Okay, and what is the minimum value of this graph? It's negative 2. You can take the minimum value. It's just the lowest number. It's the lowest number on your range. It's just negative 2. It is not a point, so just put a number. And what's the max value? None, because infinity is not a point. Okay, that's it.